Hi, I'm Amy. Let's take a look at a crazy graph with all kinds of asymptotes, jumps, and holes, and make sense of the limits that go along with that graph. First of all, the most basic explanation for limit is where is the graph heading? And it doesn't matter if there's a point there or not. I'll show you what I mean by that in just a minute. As a reminder, a two-sided limit exists if the limit from the left and the limit from the right approach the same numeric value. This would be notation for a two-sided limit as x approaches some number a is some real number, and f of x is the function we're investigating. And then the left-sided limit is this one here, showing that we're coming in with a minus sign. And the right-handed limit is right here, and that shows we're coming to the same number, but with a plus sign, meaning we're coming in from the right-hand side. So again, two-sided limit exists if and only if the left-hand and the right-hand sides are equal. And in order to be equal, they have to exist, which means they are equal to a numeric value, meaning not infinity. So let's take a look at this graph. It's got all kinds of different fun things going on here. The first limit I'd like to look at is the set of limits where x is going to 0. So first of all, let's look at the x-axis. 0, of course, is right here on the x-axis, so we're going to come in from the left and from the right towards the x-axis. So as we come in from the left, where is the graph heading? Doesn't matter if there's a point there or not. So let's come in from the left, and we see that the graph is heading towards the y value of 3. So this limit is equal to 3. Doesn't matter that there's not a point there. Again, it's the limit. Where is it heading towards? From the right, and that's our limit with the plus sign, we see that the graph is going somewhere completely different. The graph is heading towards y equals 1 this time. So from the right, we do have a limit, and this time that limit is equal to 1. So then this notation here refers to the two-sided limit. As x approaches 0 from both sides, where's the graph heading? Is it heading to one specific spot? No, it is not. It's going to 3 in one direction and 1 from the other direction. This limit does not exist. And we say DNE for does not exist. Next, let's take a look at the limits as x is approaching 2. Here's 2 on the graph on the x-axis, and you see that there's a vertical asymptote there. And from both sides, both from the left and the right-hand side, the graph is unbounded. It's going up, 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 up from both sides, heading towards positive infinity. Is infinity a numeric value? No, it is not. It is not a numeric value, therefore it cannot be a limit. We can say, however, that from both directions we are approaching positive infinity, meaning that's the direction you're heading. That's just informational, but officially when you're asked for that limit, you would say that that limit does not exist and does not exist. Why? Because there's no cap to it. It never actually hits that limit. Then the two-sided limit, well, x approaches 2 here, we also would say does not exist. Next, let's look at the limit as x approaches 3. You'll see here, I've highlighted it, that there's a hole when x is equal to 3. There's a hole at 3, -1. That's called a removable discontinuity. So what's happening as we come in from both the left and from the right, they are both heading the same place. They're both heading toward the y value of -1. So both of these limits, both the left and the right, are equal to -1, which means that the overall two-sided limit, and you can see it visually, you can see they're both heading towards the same place, so therefore that two-sided limit is -1. Finally, let's look at the limits as x goes to positive and negative infinity. Sometimes that's referred to as end behavior because we're looking at what does the graph do as it goes way out that way or way out that way. Is it going up, 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 or is it approaching an asymptote? What's happening? So first off, as x approaches negative infinity, so that's heading out this direction, very, very, very far to the left, the graph appears to show that we have an asymptote, a horizontal asymptote at y equals 0. So we would say then the farther and farther we get out on this graph, the closer and closer this f of x graph is going to get to y equals 0. Remember, the limit values are always y values. And then in the positive direction, as we go out, 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 in the positive x direction forever and ever, we are getting closer and closer to another horizontal asymptote of y equals -3. So that limit approaches -3. In the future, you'll definitely have to find horizontal asymptotes, and you'll do that using limits as x goes to -infinity and to positive infinity. I've got another video all about horizontal asymptotes. You'll also use limits in the future, not only to recognize horizontal asymptotes, but to recognize removable discontinuities like holes, jump discontinuities like we have here, and vertical asymptotes. So one last thing, I just want to play with the graph a little bit. Let's pretend that instead of having the horizontal asymptote here, the curve here off to the left just continued going up, up, up. It curved upward and goes up, up, up. In this case, if we were looking at that limit as x goes to -infinity, because that curve keeps going up and is not approaching a single numeric value, we would say that this limit does not exist because the curve is